Welcome back to my channel. This is Kidomuju from KD Concept Researchers. Please kindly like and subscribe to our channel so that you can always get our videos while it drops. On another, gives you your multiple linear regression. Now, similarly, we can also conduct a correlation analysis with the same data. Let's see if there's a correlation between these variables used. Now, how do we run a correlation analysis? Similar to regression analysis, we just go to analyze. Then here we see correlation. Remember, correlation is just on top of regression. So correlation, and then we select bivariates. Now it's not asking you which variables do you want to correlate. We want to correlate between nominal GDP and up to narrow money. So let's find out if there is any linear relationship between these variables, because it is very important to check for linear correlation between variables that are involved in a model. Now down here is asking you what kind of correlation coefficient do you wish to use. We have the Pearson, we have the Candice, and then we have the Spearman rank correlation. So we're just interested in Pearson correlation. And of course, it's asking you the test. Are we doing one tail or two tests? It is always advisable to do your correlation with a two-tail test. And this place says flag significant correlation. This is why I was trying to say that this is the strength of SPSS. Excel does not really look at the significance of the correlation coefficients, and it cannot be able to flag significant ones. So flag significant correlations, and then we OK it. Again, let's go now to our results and see the results of the correlation. Now look at this. The correlation results is usually a very big table. Now we see both the vertical and horizontal axis. Of course, the correlation between nominal GDP and nominal GDP is a perfect correlation. That's why the coefficient here is 1. And of course, it is significant. Down here, you see that correlation that are significant at the 0.01 level are asterisk twice, while the one significant at 1 level is asterisk once. For instance, there is a significant correlation between demand money and nominal GDP. You see that the coefficient is 0.000, and of course, it has been flagged. This correlation is very significant. It's 0.892 and it's significant. Also, there are so many, virtually all intersecting coefficients here are significant. Just like if you look at between money supply and demand deposits, you see that the correlation between money supply and demand deposits is here. That is 0.954 with a significance of approximately 0.000, which is 0, showing a positive correlation. So this result simply shows that our interacting variables, that is both the dependent and independent variables, have a positive linear relationship. So we are not surprised with the performance of the model, because the variables that we are used in the model have a good and positive correlation amongst them. You can see that all correlations are flagged. In fact, for every correlation, we have the Pearson correlation, we have the significant tail, and we have the end, which is the sample size. So, for instance, correlation between nominal GDP and demand deposits is 0.892, and that is significant. Of course, the sample size is 90. So this shows you the totality of all possible cases in the correlation model. Unlike Excel that uses a kind of triangular view, this one uses a square view to show all forms of correlation. Remember also that these results can be moved. They can be exported to maybe your Word documents or any other place where you're typing. by simply right-clicking on it and choose copy. Once you copy it, let me try pasting it in an Excel spreadsheet. Let me go to Excel spreadsheet. Okay, I can paste it here, right-click. And I will paste. Okay, now this is the correlation results which we did in SPSS, and now we have successfully moved it to Excel. Now, right here in Excel, you can now do your table format and every other thing that you need to do before you can now move it finally to your Microsoft Word. So this is simply how to run a correlation analysis. Now, there was another data which we use for correlation analysis, which is this water analysis. If you remember, we have this water analysis here, where we have parameters, and then we have the boreholes. Now, let's say our interest now is just, of course, the parameters. Our interest is in the parameters. So we are going to convert this data into, we are converting these parameters from column view to row view. How do we do that? We highlight the entire data and then copy. Now I'm going to create a new sheet. Observe what I'm going to do now. I will right click. Now, where I'm going to paste transpose. See what happened when I paste transpose. Can you see this? It has now converted the columns to rows and the rows to columns. So I'm going to paste this as transpose. Okay. Now we have this data now in transposed form. And this is now the data which we wish to move into SPSS. Remember that we have all these data label for the physicochemical properties. Now, in SPSS, we are going to create variable name with each of these items listed here. For instance, let me say I just want to check for the first 5 of them. I'll go over to my SPSS. Now, still on the same document, I'm going to create more variables. Let me see if I can split my screen to see the items I want to add. Okay, I want to add temperature, then pH, then conductivity, then turbidity, total dissolved solid TDS, salinity. Okay. Then we have the alkalinity. Remember, you don't have to write them in full. Then we have fluoride. Then we have the hardness. Hard. Then we have FCB. Do we still have more there? Remember, this data is the same one we have in Excel. Then we have TCB. We have THB. We have sodium. We have potassium. We have nitrate, NO3. Okay, we have PO3 and SO4. Now, remember that they are all numeric. Now, what am I going to do? I will go back to my Excel. I'll go back to Excel. Because I've created the data label, I will now go ahead and copy the data itself. Highlight the data now and copy. Then come back to my SPSS file. I don't have to type again. All I have to do is to paste the data which I have copied. So let me come back to my data view. You can see that we have created new columns here. So I'm going to paste from this temperature. Paste. Good. Now we have pasted. I can even delete this previous data because I no longer want to do anything with them now for now. So let me clear this. Good. Now we have from temperature up to SO4. Oh, there's nothing SO4, so I'm deleting it. Clear. Now, because we have entered data already into this file before, you notice that there are missing values in this lower part of the table of the spreadsheet. So what I'm going to do is I will highlight from this row 9 and make sure I get up to 40 or 50. Then I'll right click and say clear. I'll right click now and say clear. Good, my data is ready now. This is all about data preparation. Now, concentrating on this data, let's now run a correlation analysis on what you have here. Again, we'll go to analyze, then we'll go to correlate. Remember, we use bivariate correlation. Now, you see all the variables listed here. What am I going to do? I can press Ctrl A to highlight them all, and I'll move them to my variable. Of course, remember, you have to tick Pearson correlation or any other correlation you're considering. And of course, flag significant correlation. And okay. Now we'll go to our results to see what has happened. This is going to be a very big table. As you can see, this is a very big table showing all physicochemical parameters tested and their corresponding correlation. As you can see, some are significant at one tail, as I can see this one here. So it's flagged once, while others are significant at two tail. Remember, Excel could not show us the significant level of this correlation, but SPSS can show us. Now, I can right click and copy these results. Then I'll go back to Excel. If I wish to export my results, I'll come back to Excel. Maybe I want to paste it on a fresh sheet. So I'll create a new sheet and I'll use Ctrl V to paste. Good. Now, this is the result from SPSS, showing the total correlation between all the physicochemical properties that were tested. You can see that some are not significant, while others are significant. So significant ones, you see asterisks assigned to it, showing that it is significant, while the ones that are not significant are left alone. You can also see that some correlations are positive, while others are negative. Remember, we say correlation can be positive, negative. Where it is 0 means no correlation. So this is simply how to run your correlation analysis in SPSS. Thank you for watching this video. You can also check out some other videos that are prerequisite to this one on our course series in data analysis using Microsoft Excel. Please kindly leave your questions in the comment section and we'll attend to them. Also remember to like, share, comment, and most especially, please kindly subscribe to this channel so that we can always serve you better. Thank you.